Now we are going to discuss another interesting problem, mining compressed patterns. We know frequent pattern mining may often generate many patterns, but many of such patterns may share some similarity, may be very scattered, but not so meaningful if you generate all those patterns. Let's look at such an example. Suppose we finally get 5 pattern IDs. So you probably see these 5 patterns are like P1 and P2. They are very similar and their supports are also very similar. But P2 and P3, they are similar in item sets, but their supports are rather different. Can we compress them? We may first examine closed patterns. Actually, for closed pattern, there's nothing you can compress. The reason is closed pattern require the supports are identical, then you can compress them. But none of them have identical support counts, so nothing can be compressed. What about max pattern? Of course, we can use max pattern like P3 to represent all the patterns. But on the other hand, you probably see P3, this support is rather different from all the others. To use P3, you may lose a lot of information on the supports of other patterns. So the desired output actually is P2, P3, and P4. The reason you can see is P1 and P2, they share similar item sets, and also they share very similar support counts. So we may need a good measure to see what things can be compressed. The good measure could be pattern distance measure. We use this definition to define the pattern distance. You probably can look at P1 and P2 when we look at this. P1 and P2, their transaction intersection of their transaction ID. What should be the count? The number of transactions they can intersect? Actually, it's a smaller one here because every transaction containing P2 must also contain P1. So their support counts intersection should be this number. Okay. What about the union? The union actually says all those transactions, because we know all the transactions P1 must also containing the transaction of P2. So their union number should be this number. Okay. In that case, we proceed these two numbers very close to 1. Then the distance 1 minus this very close to 1 number, you get something very close to 0. That means their pattern distance is rather small. Based on this, we probably can see we may be able to define a delta clustering or delta cover. That means if we can see the pattern P, the delta cover of pattern P is finding those patterns. All the pattern can be expressed by this. The distance is within delta. Actually, you probably see P2 is a good one because P2 essentially can cover P1 because P1 just have a little less item sets, but their support are so close to that extent, we may say they are within this delta cover. Okay. So for delta clustering, we will be able to cluster P1, P2 together using P2 to represent the pattern. So that means if we do this delta clustering, then all the patterns in the cluster can be represented by one pattern P. So the problem becomes whether we should mine all the patterns, then compress them, or we should directly mine these compressed patterns. Actually, there's an efficient method which can directly mine those compressed patterns. I'm not going to get into the detail, but you may refer to this interesting paper. Okay. Then another interesting thinking is redundancy-aware top K patterns. Okay. That means we want to get a desired pattern which is similar to the compressed one, is we want to get high significance and low redundancy, these kind of set of patterns. Okay. Let's look at this A, B, C, D, 4 different kind of compression. Actually, A is a set of original patterns. Their cluster shows their pattern distance, and the color, the darker shows it's more significant, the lighter shows it's less significant. Okay. In that case, you probably can see in this bigger cluster, there are 3 patterns. They are quite significant. If you just do the top K pattern mining, that means you take the support count or other significant measure, you will only find these 3 patterns. Suppose you want to only find top 3. Then all the remaining patterns, like here in the other cluster, is completely missing. But if you say, I just do the summarization, try to find clusters, and within each cluster, try to find their centers, then you probably will find those less significant patterns. So this may not be a good balance. Actually, better balance is you take care of both significance and the redundancy. Simply says, you look at this one, they are something very significant, and they are also in the cluster center. You may want to show these patterns. In the meantime, suppose you can only show 3, you may show these are significant and less redundant. This one is significant, and also it represents this cluster. So the problem becomes how to develop efficient and effective method finding such redundancy-aware top K patterns. There's an interesting study which uses maximum margin significance to measure the combined significance of pattern and develop efficient methods to mine such patterns. We are not going to get into detail of this method. Interested readers, we may read the paper we pointed out. Thank you.